Hey everybody, this is Mr. Forrest here. This is chapter 9, going to deal with site surveys. So let me go ahead and share my screen. There we go. Fantastic. All right, so this is kind of a long chapter, so kind of bear with me here a little bit. I'm certainly know that you're going to spend a little bit more time to read it. It's not a hard chapter, but there's a lot of information. So site surveys, okay, for your wireless local area network design, okay. And again, it can be a combination of a process and procedures used to create your network. Okay, radio frequency, site surveys, evaluate your radio frequency coverage. I think we talked about this back in like chapter 1 or 2, right? We can kind of figure out what your signal strengths are. So you might want to go back and relook at that chapter, okay? Determine what your network capacities are going to be and your hardware installation and any types of antennas. Are you going to be using omnidirectional or semi-directional or a hybrid, a combination of them or whatever, okay? What are some of the environmental conditions, that could affect the signal? Again, back to the earlier chapters to help you a little bit, okay? The scope of this one here, what's the physical location, intended use for the network, number of wireless devices, performance. Are you going to allow people to use their own devices? And then who's going to be responsible to make sure they're in compliance? Some companies say, no, we're not going to allow people to do it. It's just the way it is, okay? The building construction, what is it made? Is it concrete? Is signals going to be able to permeate through the walls, or is it just going to bounce back off of it, stuff like that, okay? Gathering information from our business requirements. Gathering information is typically the first step. Again, figure out what our needs are, what our radio frequency coverage area is going to be, what applications are going to be in use, and then, what protocols. Interviewing the stakeholders, understanding sometimes we have an idea of what we want it to be, or we're going in to evaluate an existing network. We should go talk to the people who are using it, and maybe we'll get an insight to something that we hadn't thought about before, because the actual use of it, execution may be different than what was on the map or was on a plan, okay? But anyway, that being said, hey, was there ever a site survey done before? Look to see, ask the question. Maybe somebody did do it. Doesn't mean you shouldn't do your own homework. You should always do your own site survey, okay? But there might be some insight. They may have information, or there might be, blueprints or something like that you had not known about or whatever, because it was part of a site survey before. That may be in that document, okay? So, think about that for your network. What else? Are you going to allow public access to your wireless network? Your doctor's office. Are you going to allow for wireless access in the waiting room? Some companies say, no, I'm not doing that. I know it sounds great, but we're not a Starbucks, okay? Our wireless is not for our patients. Our wireless is for us, for our own business and our back office, and that's it, okay? So it just depends. Some people, make different decisions, okay? What's that coverage area going to be? And then what kind of equipment are you going to be able to use, okay? Are there any kind of known areas that may lack coverage, okay? Again, is your goal to cover all of Fresno City College, or just parts of Fresno City College? Do we need to cover a classroom, per se, that has a bunch of actual computers in the classroom that are wired? Do we need to have wireless in a wired classroom? Or do we need wireless in a lecture room where there aren't computers in there? Something to think about, whatever, okay? So what kind of applications are we going to use, okay? And how much demand for that? What is the graphics or whatever are going to be demanding for that, okay? Will voice and other applications be required, okay? Whatever, okay? Is power over the Ethernet going to be required, or we're going to have to do a whole bunch of electrical rewiring, okay, in that process as well, okay? Again, what are the security requirements, okay? Will some kind of escort be required? Does there legislation compliance requirements? Do the HIPAA laws require, or some kind of state government require us to do certain things, or corporate policies that require us to say, hey, we have to do this for X number of locations, or X number of distances, or X number of devices, or whatever, okay? Defining the physical and data security requirements, okay? Requirements for both physical environments, okay? Are those, is a wireless LAN going to be vulnerable to somebody trying to radio frequency jam, okay? Yeah, there's a whole legal world and stuff about jamming, radio frequencies. You got to be really, really careful on that stuff. Sounds great. I want to jam that frequency to keep those devices from work. It looks like, hey, it's in the movies all the time. Yeah, there's a lot of laws that make that illegal, okay? So anyway, are there things that we can do to protect ourselves, okay? Does data security ensure that the information, such as the computer data, whatever received, is for that intended recipient? Who's going to get it? Or because it has to be anybody? Again, remember our AAA, right? Okay, so AAA. Go to specific documentations, floor plans. I talked about that before. Where are, what's going to be the furnishings? Again, I don't really care if there's going to be a beanbag, but I may care if there's this whole wall is going to have a bunch of, metal cabinets, okay, because we may have an issue of bounce back or whatever, okay. Electrical specs or whatever. Again, are we going to have to do rewiring, or can we do some PoE switches and use the data and power and stuff over that? And how far are they going to be on that one? What is it going to be a tie into the existing network? Okay, if you have an existing wired network and stuff, how are you going to augment that with the wireless network? Okay, is it critical to know the details of network infrastructure? Yeah, absolutely. We need to understand those protocols for the wired versus the wireless. Okay, where's the wiring closet going to be? That's one of those kind of interesting questions, because you're going to need to have a place that's going to have to be secured, where you're going to have all your servers that are like that, your wiring racks, and so it really should be. Wired infrastructure network devices, connection between the sites. And again, I talked about electrical power requirements, perhaps, okay? Wireless capacities, okay? Physical size and the area to be covered. Number of users and devices, okay? Again, redundant little BYOD stuff, whatever. Software, hardware applications in use, and then things that could interfere with the propagation or the signal strengths, okay? Coverage and capacity factors, radio frequency range, again, how many antennas do we need to use, an active gain, so we're going to have a powered antenna to be able to get the signal part of it. Are we using directional, or are we using omnidirectional or semi-directional, okay? Wireless LANs are good use, okay? What else? Here we go. Client devices that will be connecting to LAN, okay? There's different types of stuff, the devices that we might be used. Yeah, these are some of the older pictures, go figure. Not exactly an iPhone, got it, okay. But that's okay, again, remember, contextualize and stuff, the newer devices just run faster and newer. They also have some other headaches to go with it, because, smartphones have more use, okay, kind of say. And are we going to allow that use on our network, okay? Client devices that may be connecting the wireless, notebooks, tablets, pockets, smartphones, barcodes, point of sale registers. You're a grocery store, or you're a department store, you have point of sale terminals or whatever, okay? You're a hardware store or whatever. So other types of connectivity issues and stuff. Are you going to have voice handsets, for talking, on the phone, or talking on the, voice over IP, okay? Certainly desktop computers are wireless, going to talk to our printers. E-prints has become very popular. What kind of equipments, video cameras, security cameras, are those going to be 4K or newer 8K? Okay, what's that traffic going to do to our network and stuff, because we've added all these security cameras in play, okay? Again, various antennas, so you got some maybe omnidirectionals here and semi-directional here, whatever, access points. I would never put an access point that close to the wall. Okay, I guess you could do it from here to here, but yeah, I guess if it's directional here, it makes more sense, right? You don't put an access point that have an omni and have it covered outside the building on the second floor, okay, for instance, okay? Anyway, general use of enterprise manufacturing, warehousing, retail, grocery stores, healthcare, government facility, educations, public access hotspots. The concepts behind deploying wireless networks is not proprietary, it's not controlled. A lot of times if you go to a school, say, hey, look, I don't want to know how, what you're doing. I just want to know how you're doing it. If you're covering X number of buildings, what brand are you using? Ubiquity? Okay, what brand of hardware are you using? How many access points? How are you covering a classroom? Because guess what? Once you figure out a layout of a small elementary school, aren't all small elementary schools have something in common? Could a hospital have something in common? Could a medical office have something in common? My point is that, sometimes we can connect, and in our own networking, personal networking world, I say, hey, you know what, I'm going to call up, I know the network administrator over at St. Agnes, or I know the network administrator at that, doctor's office or that law firm. Hey, what are you guys doing on your deployment stuff? I know you guys got like 3 buildings and you're 3 different floors or whatever it may be, right? How are you deploying that? Again, I don't want to know information about your clients or your customers or about your accounting or whatever. I want to know about the infrastructure, because I might want to do something similar and then go to town using that. Okay, so physical radio frequency, locating, areas and sources of interference. Again, back to that earlier chapter, determining the location of the access points, sensors, and devices that will be used in the network. Okay, arranged, through the entire locations, take throughput notes, whatever, right? Throughout, you want to take and figure out, what's going to be where and how well it's going to be. Determine the preliminary placement of the infrastructure. where are you going to put those access points? And then sometimes try it. Remember, somebody said, hey, we have the access point on a stick, and we can kind of, hold it up towards the ceiling, on a stick, because we don't, maybe it's a 2-floor ceiling or whatever stuff. Okay. And then try our signal strength from it way up there, as opposed to, do I have to spend the whole time mounting the whole thing just to be able to check the infrastructure? Okay. Perform that on-site testing, of the equipment, before you actually start doing a full-blown installation. Okay. Again, we want to verify everything that's going to go on. Okay. Frequency spectrum, okay, Wi-Fi and non-Wi-Fi interferences, what are things that could have interfered with that are non-Wi-Fi or microwave? Cordless phones aren't as common nowadays, so I don't think that's from medical equipment. Sure, absolutely. Manufacturing industrial equipment, sure. Air conditioning units, whatever. I mean, all sorts of things that are out there. Radar systems, whatever. Okay, things that can interfere with the radio frequencies. Okay. Radio survey, obtain a floor plan, again, no problem. The site survey, perform the spectrum analysis, test the point placements and stuff, take photos, the access points and stuff, with a digital camera for documentation, so we have an idea of what's going where, and then analyze the results of that. Okay. Perform a manual one, okay, wireless thing. So some of the advantages of a manual survey, very accurate based on, the actual readings that you get, throughout that building or throughout that floor or that classroom, whatever, or hallway. Physical characteristics that are tested, and we actually can kind of get an idea of, hey, this is not going to work. We're going to need to have access channels, or we're going to have a different way, or maybe part of our network we thought we were going to do wireless isn't going to work. It's going to have to be wired, or we're going to have to run wired to that room, and then we can light up just inside the room. It may not get outside the room, but everything inside that room. So, we can run a physical wiring into a classroom, set up an access point in the room. Now we covered the room. Why? Because if we try to do it from the outside, we can't get through the walls because we get a lot of bounce back. Okay. What are some disadvantages to the site survey? Sure, it's time consuming. Absolutely. Sometimes we only have one access point for testing, so our readings could be off, whatever. Okay. It requires a physical walkthrough, and some places, whatever, we may need to have somebody walk us through. It's a secure environment. I can't just walk in the hospital. I have to make sure that I'm allowed to go into different parts of the hospital. If I'm an IT person, that might require, sensitive areas for me to be able to get into. Okay. Anyway, software assisted manual sites, passive site surveys. There are active site surveys, whatever they're out there associated with access points prior to taking that. Okay. What else? ESS showing passive. So here's an idea of saying, hey, these are some passive surveys. Okay. Predictive modeling survey. Okay. To try to figure out to say, hey, I wonder what this is going to do, in this physical environment. Okay. Again, thickness, glass, walls, doors, kind of things like that. Is it a concrete structured building? Like, again, some of these high-rise buildings, they're a lot of steel girders, and then they have concrete floors. They're not built up on wood going up 20 floors or 5 floors or 2 floors or whatever. Okay. And there's a lot of steel. Okay. And so what is that going to do? Again, what kind of furnishings and stuff, heights of the ceilings. Okay. And so the predictive modeling, okay, what are some of the advantages? Advantages to predictive modeling is to try to anticipate is maybe we can figure out some of these things without having to do the full site survey, limited time on site, doesn't require a complete physical walkthrough, allows for easy adjustments. Okay. And we can model different scenarios. Okay. What are disadvantages? Well, the survey may be similar, but the location's physical characteristics could be different or whatever. Accuracy limited to what's been put in. Okay. And so garbage in, garbage out. Got to be careful with that, and requires extensive knowledge of the physical property of the installation to figure out what your attenuation values, your signal losses are going to be. Let's see, almost done here. Internet-based predictive modeling. Okay, these kind of softwares that are out there, some companies here that are available. I think personally, from me and stuff, I don't use predictive modeling and stuff. I mean, I'm going to go in and do the testing myself. I'm going to evaluate it myself. I want to spend the time because it's going to be my name behind it or my responsibility there that's going on with that. So anyway, hope this helps. This was chapter 9. Let me go ahead and stop the share, and I'll end the recording. So you have a good day on chapter 9.